Find the GCF and LCM for 5 and 9. To get the GCF and the LCM, I have to get the prime factorization. So let's get the prime factors of 5, make a 3, and the prime factors of 9 to make a 3. So what by what may give you 5? 5 is prime. 1 by 5, and no other factor pair may give me 5. So this 5 is prime, so I'm gonna make a circle around because I can't write 1 by 5 in this tree because 1 is not prime and not composite also. So I'm searching for the prime factors. So the prime factor for 5 is itself 5 only. So I'm gonna make a circle around, and let's factorize this 9. What about 9? What by what equal 9? 3 times 3. 3 is prime and 3 is prime. So now I factorized 5, factorized 9. To get the GCF and LCM, I have to array. Array means what? I write these prime factors under each other in the array form. So the factors of 5 will equal 5 only. What about 9? It will equal, the first factor is 3. Can I write these 3 under these 5? No, it will be far away because it's not the same as 5. It's different. Times, what about this 3? It will be far away also. Now I have to get the GCF. What is the GCF? The GCF is the common factor between the two numbers. The numbers or the factors which are in array. Do you have array here? No, no one under 5, no one above 3, no one above 3. So there is no any common factor. In this case, I can say that the GCF is 1 because 1 is common factor for all numbers. So I'm gonna put 1 as the GCF of 5 and 9 because there is no common factor between them. So what about the LCM? I can get the LCM by 2 ways. The first way is the prime factorization. In the LCM, I will take all the factors which are in array or in a column. So I can take 5. This is 5 in a column. This 3 is in another column. This 3 is in another column or in a separate column. So in the LCM, I'm gonna say 5 by 3 by 3. So it will be 5 by 3 by 3, and 3 by 3 equal 9, so it will be 5 by 9, it will equal 45. In another way, I can write table 5 and write table 9 and get the first common. What are the multiples of 5? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. What are the multiples of 9? 9, 18, 27, 36, 45, and so on. So who's the first common between them? 45. So 45 will be the LCM. Now let's get the GCF and LCM between 11 and 3. So 11 is a prime number, 3 is a prime number, and I have one trick. The GCF between any two prime number is what? 1. The LCM between any two prime numbers is their products. So here I can say that this 11 equal 11, this 3 equals 3. So what is the GCF? There is no any common factor, so the GCF will equal 1. What about the LCM? LCM, I will take all the columns as I said, so it will be 11 by 3, it will equal 33. So as you see that the GCF is 1 because they are two prime numbers. The LCM is 11 by 3 because both of them are prime numbers. The GCF and LCM between 12 and 4. To get the GCF and LCM, I have to factorize 12, factorize 4. But first I have one trick. Can give me the GCF and the LCM without calculations, or at least to make sure after I bring them. So 12 is a multiple of 4. In this case, when the big number is a multiple of the small number, so the small number will be the GCF, the big number will be the LCM. So let's make sure. So this 12 factorized 12, it will be 3 by 4. 3 is prime, 4 is prime. No, I will factorize it again. It will be 2 by 2. 2 is prime and this 2 is prime. What about 4? It will be 2 by 2. 2 is prime and 2 is prime. Let's list the prime factors of them. I have here 12. 12 equal 3 times 2 times 2. What about these 4? I will list the prime factors of 4 in the form of array under the factors of 12, so that I write each factor under its friend. 2. Does it have friend? Yes, it can make array under these 2 because they are the same. They are common and they gonna make array. So what about these 2? Can I write it under 3? No, but I can write it under its friend 2. So it will make array with these 2 also. Do you have any more factors for 4? No. Now I can get the GCF and the LCM. GCF is picky, so it will take only the factors which are in array. Who are in array? These 2 and 2. This is the 2 factors in array. So the GCF will be 2 by 2. I take each number from the array once. So 2 by 2, it will equal 4. So the GCF here is 4. What about the LCM? LCM takes all the columns. So I will take the first column 3 by, second column 2 by, third column 2. Now I have 3 by 2, it will equal 6. 6 by 2, it will equal 12. Now here I ensured my trick. The GCF, as we said, is 4 and the LCM is the big number, which is 12.